All right, so I'm going to go through this quickly today, and then you're just going to have a bunch of practice time. If you were not here yesterday,
Got it. I literally have it.
we have, what's the number one rule, like when I'm doing a lesson?
Brandon.
I specifically asked Brandon that question. So when I'm talking, I shouldn't hear other voices. You're going to have plenty of time today to practice, and I don't care if you work together when you practice. So when I'm talking, if you did not grab, if you were not here yesterday, you need to grab one of these. If you were here yesterday, then you need to grab one. Oh, actually, and you need to grab this too if you weren't here yesterday. So if you were here yesterday, you still need that. So I'm not going to, you don't need to come up now. You'll have some time to grab it. There's plenty of practice time today. I meant to have you do it while I was checking, and I totally forgot. So on the first one, number one thing you need to get out of this lesson. Actually, there's two number one. You have got to be able to pull out the slope and the y-intercept from an equation. There's no, it drives me crazy when we can't do it because it's just a lack of effort. Now, it'd be one thing if I said it's closed note and you have no notes, then you'd have to actually remember it. It's not closed note. Have a page where you can easily find it that tells you how to pull out the slope and the y-intercept. If you're not doing that, it's your own fault. You don't have to know how to do it. You just have to know where to find it in your notes. So, and you can only, this is another note for that same page, you only have a slope and a y-intercept when y is all by itself in the equation. If y is not all by itself, then you don't even have a slope and a y-intercept. There is no slope or y-intercept in this equation. Y is not by itself. So, once we do determine that y is by itself, which one is the y-intercept? Explain how you know that.
Because it's the number that's without the x.
Perfect. It's the number by itself, we've said, or the number that's not with the x. That it doesn't matter. It's not first number, second number. We sometimes get into a habit of thinking the first number is the slope and the second number is the y-intercept. That's not the way it is here. First number is the y-intercept, and the second number, which that negative sign is glued to that second number, the second number in this one is the slope. Again, it all depends on where the x is, really. The number with the x is the slope. The number by itself is the y-intercept, or basically not with the x. So that's the slope. Don't forget the negative, too. I guarantee you probably about 7 of you forgot the negative. 6 or 7 of you forgot the negative with the negative 3. So I'm going to go over how to graph that much later, because we did it yesterday. I'm only going to do it for the people that are still a little confused. Mainly, we're going to focus on how to do this one today. Who can tell me how to graph it in this? How would you do it?
You would make an ordered pair by multiplying 2 times 0, then you pull down the cancel out the 0. Then you have 5y equals 100. And you subtract 5 from 100. I don't know whatever you get. 95?
So why would you do it that way?
Because you want to make an ordered pair because there's no slope and there is no y-intercept.
Well, what do you mean you don't want to make an ordered pair? Why am I making an ordered pair?
Because that's the only way you can put it on the graph.
What are you talking about? Put it on the graph.
You know,
How do you know that works?
You just said, leave me alone.
Yeah, that's a great answer. Just
Okay.
pushing you a little farther. See how
I can't
much you
take the
really know
pushing.
about it. So here's really what you're doing. Now there's a process I'm going to give you in a minute that we've already done. It actually was on. Have a copy of it? Yeah, it was on the white sheet. A long time ago, I gave you a white sheet that tells you how to graph these. The yellow sheet told you how to graph these. So there's a process. We're going to go through it. I'm going to show you how to do it again. But I'm going to try, and some of you this will work for really well, try to make you understand what you're really doing. And this might be all you need. You may never use that process a day in your life if you understand what I'm about to tell you. What did we say a line is? It's all the answers, right? That's the axis. That's what an axis is. A line, the line that we graph on over the axes, those are all the possible answers to that equation. They will make the left side equal the right side. Same thing here. the line we graph will make the left side equal the right side. So if you can just come up with the values that make the left side equal the right side, that's all you really have to do. If it's easy to do, if you don't need to use the process of plugging in numbers because it's a really easy equation, and a lot of times I give you pretty easy equations, you just need to come up with x and y values, and you're going to need two ordered pairs. So you'll need one x and y and then another x and y, because if I only have 1 point, I don't know where to graph it from there. So let me show you what I'm talking about using that same equation, and I'm going to actually do it both the what I would like to call intuitive way, meaning you just kind of can figure it out, and then I'll do the process way where you just go through and you do it. I'm also going to zoom way in. Too far in, can't see it. All right, so here's the equation. 2x plus 5y, right? That's the equation, right? And we just said a line is just a bunch of points that make that true. Can anybody just on their own give me an x and a y that will make that true? What?
Not for all of that. I think it's like 2 and 50.
Well, we can test it. Let's see, 2 and 50. So 2 for x?
Yeah. 2 for x
So
and 50 for y.
2 for x, 2 times 2 would be 4, 50 times that will be that. Does that work?
No.
And a lot of times you can just try out different numbers. This is a big number, so it's not even as easy as it would be on one of my exit tickets, but this is absolutely 100% a way you can do it if you just kind of get what I'm saying.
20x,
So what would 20 times x be? I'm sorry, if x was 20, what would 20 times 2 be?
oh wait, no, 10 times.
So you want to say 10? So if x was 10, so we're saying x is 10, what would this be?
20.
Be 20, right?
Yeah.
So what does this need to be? The 5y needs to wind up being what? What plus 20 is 100?
80.
80, right?
Oh,
So this needs to be 80. Well, what times 5 equals 80? How would I figure that out? Basically, it would be this equation here. 5 times what is 80?
isn't that like 16?
It is, because you divide by 5 from both sides. 5 goes into that once, and it goes into 30, 16. So if x is 10, y would have to be 16. And when I plug that in, I get 20 plus 80 equals 100. That's all we're really doing. This whole other method I'm about to show you, we're just doing that. It's just that we always wind up using 0 to plug in, and we plug in 0 for x, but then we plug in 0 for y instead of plugging in different numbers for x. So give me now that we've done one, can somebody give me another? Oh, so here's an ordered pair that would work. So 10, comma 16 would work. That will be on the line that we create because it makes this a true statement. Can anybody else figure one out? There's a ton of them.
Does that mean you can just go up and down with those two numbers? Think it's saying
Not necessarily, because you're multiplying times two different numbers. If you were multiplying times the same number, then they would be in the same proportion, but we're not. So you got to kind of figure it out. So just figure it out. Like plug in a pretty simple number to do math with that, and you're probably going to be able to figure out what y is. I'm going to give you one that I use in a second if nobody gets it. Really hope you guys are. Because when it comes time for you to work, I'm really frustrated if I answer a lot of questions over here.
Oh, Paul's gonna have questions. Taylor?
What about, what's 25 times 2? Pretty easy number probably to work with, right? Because if I make x 25, and that comes out, so that now becomes 50. 25 times 2 is 50. What's that got to be?
10.
It has to be 50.
So what times 5 is 50? That's a pretty easy one, right? So y had to be 10. So there's another one. So 25 comma 10 will work. You can, and then that's done. I'm done right now. Now there's a little bit of a problem because these are such high numbers. That's going to be tough to put on this graph because I have to make this graph count by 5s because because this equation has such a big number in the end of it. So it would go all the way up to 50 now, and then 5, 10, 15, and then that would go all the way to 50 at the top. So putting 16 on there, I could guess and I could estimate about where this is going to be, but it's not the greatest point. This one's fine because I'm ending in 5 or 0. Anytime you're ending in 5 or 0, those are going to be on there. But this is all you're doing is just figuring out what ordered pair, what x and y will make this side equal that side. So now to the process way. If you were confused by that, you were lost, ignore it. Here's the process you can do.
You got Bob Saget.
Yeah, I knew exactly who Bob Saget. We were good buddies.
What?
I'm just.
Oh,
I know. I used to watch that show growing up. He was labeled as America's
Funniest Tony.
father. Like everybody in America thought he was like the ideal dad, like because of the show.
Yeah.
All right, so here's what you're gonna do. I'm gonna do it in different colors now. So for the first ordered pair, again, this is if you don't understand what I just did, just do this. You're basically following this sheet right here. It says, if you want to look for it later, steps to graphing a line from a linear equation in standard form, and it should be a white sheet. You are going to take x, and you're going to say, well, what if x equals 0? What would y then have to be in order for this side to equal that side? So basically, this side has to be 100. So what happens if x is 0? What happens to this term right here? Oh, let me get rid of that. It goes to 0, right? Because I'm going to say 2 times 0. I'm still going to have the plus 5y equals 100. Well, that's just going to go away. Anything times 0 is going to go away. That's why we choose 0 when we do this. It's going to make one of the terms just go away. So my x is going to be 0, and I just need to solve out and find out what y is. Well, if I have 5y equals 100, I got to find out what number times 5 is 100. Probably you can guess it. But if you don't, then the way you solve for it is to divide by 5 on both sides. Whatever's next to the variable, whatever you're multiplying, you do the opposite and divide by that number. So we get y is 20. So you could say if x is 0, then y has to be 20. And that will make the left side equal 100, which is what it needs to equal. So here's another ordered pair that works. X was 0, because I made it. I said, well, what if x is 0? And then I figured out that y would have to be 20. Now we're just going to do the same thing, only now we're going to say, well, what if y was 0? What if y was 0? All right, well, if y was 0, I'm just going to do the same thing, only now I plug in 0 for that. So I have the 2x, because now x is back in the equation, because I'm replacing y. Ah, man, I messed up. I wanted to do this one in blue. There. So blue. I'll finish it off. So now, oh, equals 100. So now, if that's multiplied together, that just goes away because 5 times 0 is just going to be 0, so we don't need that. So now I'm just really saying, all right, well, 2x equals 100. Again, you could probably guess at the answer to that. That's where you guys guess at. Yeah, 50. But the way you would do it if it was harder math, divide both sides by 2, and sure enough, if y is 0, then x is 50. So now that's another point that would work. This time, though, the x is 50, not 0. The y is the 0. So again, as long as you come up with an x and a y that makes that side equal that side, I don't care how you do it. I do want you to still show me that those 2 points make the left side equal the right side. But you don't have to use 0 if you can just immediately see there are other numbers that will work. Now you would graph that by putting, so we'll do 50, 0 in blue. We will do, oh wait, no, what was it? 0, 20 in red. I will also drag a line on top of those. to show you that it looks like that. And we said that every possible answer to that should be on that line, right? That's what the line is. It's all the possible answers. Hold on just a second. And I said these are possible answers, right? So these better be on that line. So let's look at the line. 25, 10 would be 5, 10, 15, 20, 25, and then 5, and then 10. Sure enough, right there, right on the line. Now this one's a little tougher because, again, we don't have 16 on the graph, but 5, 10, 5, 10, 15, and then you can see it's just barely above that corner, which makes pretty good sense. So this is what you're going to do. You're going to be graphing. Now, you're going to graph two lines. So every line is going to have two ordered pairs. So this one I use the red and the blue. Then if I had a second equation, I would have to do that over again and put the second equation on there also. And what did we say is true about that point where they cross, where they touch? That is your answer. Every point on the red line satisfied the red equation when we had it up before. Every point on the blue line satisfied the blue equation. That one point is on both. It's on the red line and on the blue line. So it's the only point that works for both, which means it's your answer. So where the lines touch, this is the other biggest part of this, besides knowing the slope and the y-intercept. The other biggest part is knowing where the lines touch is the answer. Got to know that part of the bare minimum to again, I'm not even going to promise that will pass the exit ticket, but it'll at least probably get you around a 50%. No, between that and knowing the slope and the y-intercept. One quick question. What if you graph two lines and they're parallel, they don't touch? Then what do you do?
They go forever until they touch, right? Or they just
No, if they're parallel, they'll never touch. They will go on forever, but they will still never touch. So what does that mean, though?
There's no answer.
Yeah, it means you literally said there's no solution. There is no number, no ordered pair, no x and y value we could ever plug in that will work for both equations. What if you graph it and one line falls right on top of the other line, which will happen because they like testing you on those weird situations. What's that mean?
Is all possible?
Yeah, don't the lines touch everywhere, like an infinite number of points? So it's infinite solutions. There's only three options. It's infinite solutions, one solution, or no solutions. You can't have two, or four, or three. It's one of those three always for a system of equations. Or really when you solve variables. Sometimes when you solve for variables, when you have, we'll actually do that as the next topic we do. We'll solve without graphing. We'll solve for x and y, and sometimes you will get no solution, infinite solutions in that also, or one solution. All right, so you can go ahead and practice. If you can do these problems, that's your exit ticket. I mean, I'm just going to give you problems just like, actually probably easier than what's on this. Now you can go ahead, you can take the thing, trade the phone out, you can go after him, after her. What was I going to say now? Oh, on this particular worksheet, I didn't create it, as you can probably tell. You will get, when you solve out some of the problems that are like this, which are on the new worksheet, today's worksheet. It's the one that says on the front 9, 10, 11, and 12, I think. You will get fractions sometimes. You just have to do your best to figure out where that fraction would be. So for example, is anybody writing any of this? Are you still writing it? All right. If somehow you get a fraction, you may have to figure out where it belongs. Like let's say, so ignore these numbers now. Let's say these were going up by 1, 2, 3, 4. And let's say one of the numbers was 3/2, 0. If you get a fraction, you just have to figure out, well, where would 3/2 be? Well, that's 1.5, so it would be right here in between. Just do your best to estimate where it falls in between the numbers. Doesn't have to be super, super perfect, can still be okay to figure out the final dimension.
What kind of, is he of God?
Because you know, like think about it. They say that math is for everything, but
Oh.
math is for everything. He wants to make it
No,
math
he's
for
not.
everything.
Actually, one of the
He
big
wants to
guys
make
who created it was
all.
a lot of the Greek mathematicians are responsible for a lot of it. Do you guys remember the Pythagorean theorem, a squared plus b squared?
No.
It's a Greek guy. Greek, Pythagoras, the Greek. Socrates, Greek. There's some other theorems that are Greek people, I can't remember. Plato is, I don't know if he was a math guy, he was more philosophy, I think. But I mean, most of, or not most, but a ton of, all of our educational stuff comes from Greek science, Greek math, Greek, not really Greek mythology, because
That's
mythology means implies it's not true.
So you say that if mythology isn't true, then math isn't true.
Well, the word myth implies not true, right? It's called, we call it mythology, so we don't apparently think it's true.
What kind of car you drive?
Why do you think everything?
You just told me to go the wrong way.
What kind of car you drive?
I think we had that car. Toyota.
Oh, you have a
Truck.
Prius?
Diploma.
Oh my gosh.
No, I gotta have a truck, dude. I got a boat.
Nope.
Struggle.
I bet they squatting when you put on that boat.
Did I not talk about
I love
For
it.
these.
Although I don't do it as much because of
For the.
red tide.
Ride
I would love to take kids. I used to actually take a bunch of kids, different kids, like some of my friends that have kids. I take them.
That'd be awesome.
Just ride them.
I'll go.
I want to go.
My dad
Oh, yeah, once again, reminder.
My dad had a boat.
So one of the sheets is all rise over run and y-intercept, because every single problem, y is by itself. One of the sheets, though, has some problems that are like this, where y is not by itself. So you need to figure it out this way. Those are the ones where you might get fractions, and you just have to kind of estimate where it would go on the graph. You will never get fractions when you do rise over run, because you're picking the y-intercept, and then you're just counting. You're not doing any math. You're just counting left and right and then up and down. If you want to copy this down, once you have done your, and I'll probably do one in a minute, once you have done your y-intercept, and then you turn your slope into a fraction, this is what you do after that. This kind of summarizes steps 4 and 5 on the yellow sheet. If it's a positive run, so the bottom number is positive, you count right. If it's a negative run, you count left. If it's a positive rise, you count up. If it's a negative rise, you count down.
Is it right paper?
I'd write this down on your sheets, like just on the worksheets themselves. That way you don't have to keep looking back and forth between notes. You can just look right at your worksheet. Yeah, just do it right on the worksheet. So I know, on the new sheet from today, you might want to start with, oh, is that today? Yeah, I can't read it. Man, I can't see. 4. So you might want to start with 5 and 6. Wait, no, that's not right. That's the old sheet. Yeah.
9, 10, 11, 12.
Oh, somebody, I think it's supposed to be the new sheet, but somebody put it back on that pile. That's fine.
Oh, hold up. Are we supposed to do both?
Yeah,
Oh, there's different.
because
ones.
there's no problems on the one from yesterday. There's no problems that don't have y all by itself. Everything was y by itself. So if you'll look at the new one you got today, some like the 2 bottom problems, y is not by itself. Or the top 2 problems on the second page, y is not by itself. You need to know how to do those. Those are why you need to know how to do both. I don't care which ones you do. I do some where y is all by itself. Maybe do some that have fractions for the slope, some that don't have fractions. And then eventually when you're comfortable with those, I would go to the other one where some of them don't have y all by itself and make sure I can do those. This is your practice for the exit tickets. Yeah.
What is it?
Tomorrow. Oh, sorry, next class. Yeah, let me get the test.
So I have some kind of dyslexia. I have ADHD. I have like forgetfulness. I have mind control. I memory loss.
Oh, yeah, exit tickets.
Start with that on Thursday. Start with that.
I
Okay, start with that. Negative. Oh, what happened to us? So how did you get that? So it's gonna go off the graph.
Yeah.
Okay, good. And then for this one, we start at that. That would
Gotcha, I
be
think I have
1,
mine.
negative 101. Perfect. Now draw your line through both of those.
What are your
And you probably can see where it's going to connect already without me drawing it, but oh, I forgot to tell you, your final answer is going to be where they touch, but you need to write it in the format of a, do I have, oh wait, here it is, I'll just do this one. So my final answer here is 1, 2, 3, 4, 5, 6, 7, comma 3. So this is what you have to write for your final answer, right there. In like ordered pair form.
Okay.
Wait, so we write down where they cross?
Yes, the x and the y value where they
So,
cross.
I
That's
like
your final.
so-
If they don't cross, then you might write no solution. If one line's right on the top of the other, then you write infinite solution. And I'll walk around. I don't care if you guys work together, but remember that other person is not taking your exit ticket for you. So you need to make sure they explain to you how to do something if you don't understand. And then if you have questions, you can always ask me as well.
Is that correct on this part?
Oh.
So you see how this is going down, it's gonna go down, because it's pretty negative. So I'm going to have to switch it around. Oh, I have to switch
Well,
it
but
around.
you didn't switch them both. You only switched one of them. Make sure you switch both of them.
Yeah, I
Yeah.
caught myself. Yeah.
So the very first one on the new sheet goes off the graph. We said if that happens, you switch both directions. So if it was right and then up, you need to go left and then down. If it was right and then down, you need to go left and then up. Just switch both of them, not just one of them. Wow, that's sweet. Alright, so I know you weren't here, but it's like, do you remember that stuff? So you may
have
have
to go back to the video.
You may not have even gotten to that in Miss Bailey's class, when we were way past it. So then you came over to us and we had already done it, you literally never got it. Now you did do it. It's an eighth grade. Well, I mean, you were supposed to.
Wait, what was it?
So you have y, so here's the first thing you need to understand.
Negative 6 is not
You're supposed
Is it yours?
If it goes off the ground.
We're supposed to do that in sixth grade.
But wait, it wouldn't matter.
In class, I ended up getting sick and being hospitalized, so I got.
Where did you go to middle school?
No, I'm sorry.
So wait, why did it touch?
So the first thing you need to understand is that I graph these way different than I graph these. Wow, what's different on those? I need a more
Okay,
specific
so
question.
these all have fractions.
No, they don't all have fractions.
No, these ones, all these ones are like.
But I circled this too. This is circled also. That is, there's something that's the same between everyone that's circled.
Okay, with these, it has X and Y. These,
Well, they all have X and Y.
yeah, the thing about this is this is not, yeah, it's not slope intercept.
Exactly.
This is.
You graph slope intercept form completely differently than you graph on standard. These have a y-intercept and a slope. There's no y-intercept and a slope.
Me too, I think I just the answer.
Doesn't exist. Now, you could, if you really wanted to, you could take these and rearrange it and solve for y by moving everything else to the other side, so the y is by itself, then you have a slope. That's a lot of them. There's just another way to graph it. So these, you're gonna do the y-intercept, and then you're gonna, so that'll be your first point.
Yeah, I did.
I might have one that you can borrow, just leave it with me. I am gonna make some more, so I wanna keep this one to make a copy. Yeah, here you go. So this has everything, you know, it's a lot of detail, so you need to practice with it, because just trying to figure it out on the quiz won't work. But it tells you, first step, basically put a point on the y-intercept.
I'm successful.
Then, your second step, it says if the slope, so which one's gonna be the slope, then we'll say it's in. negative. Don't forget that little negative guy. So it says if you don't have a fraction, you need to make the slope into a fraction. But we already have a fraction there, right? So we don't do it. Just, it even says, well,
But making it a fraction like
yeah,
this one.
right there. It even said right here, if it's already in fraction form, then just go to step 3. So this tells you everything. And you'll actually read it, follow it, most kids.
Oh, yeah. Like with this one, you got the.
Exactly. So you change that into a fraction by doing that. Then it says in step 3, next to that fraction that you have, whether it already came in the equation or whether you made it, next to that, you're going to write rise over run. Now, when you have a negative fraction given to you, make the top number negative and the bottom one positive. So it would be, well, I want you to write that slope next to that rise over run.
Yeah, no.
Perfect. Well, again, make sure that negative is that 1. You need to know that number is a negative number, because if you look up there, now I would now copy, you see what I have written up there? Copy that like at the bottom of your sheet. Or maybe the bottom of them, but at least one. Because you're going to use that to tell you now that you've done this step, that's going to tell you, okay, which way do I go? Which one? Yeah, no, you got this one yesterday. Did you not get it yesterday?
No. Okay.
You should have if you were here.
I was here, so what happened was, I did, I had to put it apart, and I put this paper. Because I thought it was the same paper that you said you did.
That's right.
I haven't missed that much school, right?
Quite a bit. Why? Alright, I'll come to you guys next. Were you able to do, like, can you tell me what the y-intercept is out of an equation?
I think so.
So here's what I want you to do. For every equation where you haven't done this yet, and this includes the second page, I want you do, what's the variable that represents the y-intercept?
Almost.
What's the variable that represents the y-intercept?
X.
No,
What?
x and y are what are pairs.
3. Not 3.
That's not a pair.
I don't know.
Y equals mx plus
B. Yeah.
b. So I want you to write the letter b and then equal. And then from each equation, I want you to pull out the y-intercept. I'll just write it next to it. And then when I get there, I can check and see if you're doing that part right. Alright, so you got all this, right? So again, first step, find the y-intercept of the equation and put a point on that number, on the y-axis. So I don't care which one you start with. Pick a problem. The y-intercept. There you go. So what's the y-intercept? Perfect. So put a point on -3, exactly on the y-axis. That's right. So now, from that point, you're going to look at, well, so do that since you did it for that one. Now do that for that one.
Yeah, that's right.
Okay. All right, so now, from this point, you look at your run and you see what number,
I just thought it was because I ripped it
Run.
off.
Oh, rise over run.
Oh.
Well, I'm glad I just called that. I didn't even notice that you had written run over rise on the other one. Always rise over run. Did I just hear what I thought I heard? All right, gentlemen back there. Work. All right. Because this is that point where I tell you, you need to stay focused. Because you know everything we're doing in class, but then it comes sometimes exit ticket time and you haven't practiced enough. You've got to practice, Brandon. Then you should do fantastic. So, now you look at the run number. What's your run number?
Or not everyone.
Positive one. So you look over here. If your run number is positive, you count right. So from your y-intercept, you're going to count right.
Have this one. We're supposed to do this one.
Now you look at your rise number, which is what? So we would normally count down 6. What's the problem with that?
There's not enough space down.
We go off the graph. So if and that will never happen in something else. But on the inverse. So instead of going right and then down, you're gonna flip both of them. So you go,
Left and up.
Literally not.
and the same numbers apply, so left one, up. There you go. It's not.
What is it? I need to think.
It's a, energy powder.
Where?
From where?
Yeah, where is it?
It's so cute.
It's the generic one at Walmart, made by Walmart, Great Value brand, I think. I like the grape flavor. And they don't actually have that in any other, like, any name brand. I couldn't find grape.
I've had it. It wasn't great. It was my good.
I've got a bunch, like, I've got some berry tropical fusion that is actually the Mio brand, which is, I think, like the first one that came out.
Oh, cool.